Hello there, I'm Thomas. That is a British American pilot flying the Boeing 777-300Erx in tonight's flight from Zurich International Airport. We're going to be overflying Zurich, Switzerland, Germany, then coming back to Zurich International Airport, runway 1449, Lszh localizer, lighting surrounding now in the cockpit for the pre-takeoff preparation of the PMDG simulation and Microsoft Flight Simulator X Boeing 777-300Erx. I'm going to start showing the cockpit instrument that displays the functions of the Boeing 777-300Erx aircraft. I'm going to start with the primary flight display. I will show you the airspeed indicated, the airspeed selected from the autopilot and flight director system panel, the ground speed, the radial altitude above the ground level, the magnetic heading and track, the barometric pressure above the sea level, the barometric pressure of the outside atmosphere, and the altitude selected from the autopilot and flight director system panel, the target altitude. We have also the vertical rate of climb and descent of the aircraft in tens, hundreds, and thousands of feet per minute, the vertical speed indicator. We have the attitude indicator, the pitch slider in degrees, and the bank angle in degrees. Also the Ilsloc localizer and the flight director crossbars for manual guidance of the aircraft, and the autopilot crossbars for automatic guidance of the aircraft. We have the angle of attack of the aircraft at its size, and the flight mode demonstrator with the autopilot and the auto throttle later on in vertical navigation mode. We have also the navigation display. The navigation display that displays the airports, the waypoints, the GPS position. You can see the terrain reflections from the weather radar and the weather reflections. Also the terrain map and the elevation of the terrain level around you. You can see the distance of the airports where you are located. You can see other aircraft flying around you over here in the navigation display. So you have the magnetic heading and track, the magnetic north pole and the true north pole and magnetic variation again where we are depending on where we are in the world. You can see other aircraft using the DSP and ADC transporter, transmitter receiver that transmits and receives our own position, altitude, direction, and airspeed, and receives from other aircraft and displays them with the diamonds state aircraft symbol. So you can see the traffic of other aircraft in your navigation display. You can see the distance of other aircraft, the altitude difference, the direction, and the airspeed. And you have the TAKEOFF system, the traffic collision alert system, generate the traffic warning in the navigation in the primary flight display. You will see it later. We have also the wind direction and speed, the ground speed. We have the next waypoint we're going to be overflying, so we're going to generate our route using the flight management computer, a complete flight plan or flight path using the inputs of the data of the aircraft and the airport, the departure airport, the destination airport, and the departure runway and the destination runway. So we're going to use the takeoff weight of the aircraft. That includes the empty weight plus the passenger plus the cargo plus the trip fuel plus the reserve fuel plus the taxi fuel. So we're gonna have the takeoff weight, and we're gonna input that in the takeoff performance page of the CDU of the flight management computer, the FMC. So we're gonna have the calculations for the takeoff speed. We're gonna use the flaps and the horizontal trim stabilizer, the gross weight, and we're going to have also the selection of the runway, the conditions of the runway length, the slope of the runway, the wind direction and speed, if the runway is dry, wet, or ice, the air density, air pressure, and the temperature of the air, and other data. And we're going to have using the takeoff weight of the aircraft and the minor dynamic chord position of the aircraft in terms of the center of gravity and the horizontal trim, the horizontal tail trim stabilizer. We're going to have the flap settings and also the takeoff speed, the V1, V-rotate, and V2 calculations. So I'm going to show you how to do that. We're going to use the flight management computer here, and this is going to be displayed like a flight plan over here in the navigation display later. So you're going to see also the takeoff speeds also. So I'm going to show you then Also, we're gonna make a complete flight path or flight plan for route using the flight management computer, the route creator. We're gonna insert the departure, as I said, runway and airport. We're gonna use the seeds, that are in the departure. There may be waypoints and fixes, and the destination, airport and runway. The stars, the star terminal arrival, and the Lszh localizer. We're gonna use the destination, airport, runway, Lszh localizer, for horizontal localizer, guidance and vertical glide slope, the Lszh system of the destination airport, the vertical glide slope, and the Lszh system, the instrument loading system. So we're gonna have a complete route using climb, cruise, descent, and approach procedure. So I'm gonna show you how to do that using the flight management computer, and this is also gonna be interconnected to the autopilot and flight director system panel. Over here, the LNAV and the VNAV is gonna use the FMC input. So we're gonna have the guidance of the aircraft either manually or automatically for the flight plan with using the LNAV and the VNAV. The lateral navigation and vertical navigation of the autopilot and flight director system panel. So then I'm going to show you the autopilot flight director system panel, the FDS, the autopilot engage and disengage switch, the throttle left and throttle right, engage and disengage switch to the flight director, and engage and disengage switch, the airspeed select knob. You can select an airspeed in nautical miles per hour, knots or Mach speed, and we can select modes for commanding the engine thrust for this, and also the flight control. So we're gonna have a fixed thrust mode for takeoff, go around, or climb, maximum continuous thrust, or idle thrust for descent. So we're gonna have during the fixed thrust, like the climb, we're gonna have the horizontal trim stabilizer adjust the airspeed of the aircraft by how fast the aircraft climbs its vertical flight path. Also, when we descend using the idle thrust, which is a fixed thrust mode, also the horizontal tail trim stabilizer commands from the auto trim system, or the horizontal tail elevator is gonna adjust how fast the aircraft descends, and this is gonna adjust the airspeed of the aircraft. So we have also the variable thrust modes. As we cruise, we have as the aircraft maintains a horizontal flight path, like in the cruise or the approach and landing. We have the variable thrust, in which the airspeed is been adjusted to override the thrust commanded by the engines, which command the FAREX, the fuel fluids, the digital electronic control computer. So we have also the General Electric 90J92 200 engines, which are installed in the Boeing 777, which are two-butted engines. We'll show you also that how to use them. We have the LNAV and the VNAV. We have the bank angle limit select knob for the cruise level. We have the heading select knob and the heading hold switch. We have the vertical rate of climb and descent that determines the trigonometric angle the aircraft climbs or descends, the FPA flight path angle, or the vertical speed in tens, hundreds, and thousands of feet per minute of climb or descent, the VS, the vertical speed indicator. So you're gonna see also that displayed in the primary flight display of the vertical speed indicator. We have also the vertical speed hold switch and the adjust slider. We have the altitude select knob and the altitude hold switch, the VOR localizer for an Lszh localizer approach, and the approach switch for the auto land function of the Boeing 777-300Erx. We have also the thrust levers. I will show you how to use the thrust levers to modify the thrust commanded by the engines. The thrust power that propels the aircraft forward. I will show you also that. You can use the thrust levers over here, move them forward, left, and you will increase or decrease the thrust power from the left and right engine. We have, as I told you, you can see here the engine power, the autopilot flight director system panel. Here some systems. So we have the General Electric, as I told you, G90 turbo controversial engines installed, one in the left wing, one in the right wing, for symmetrical providing redundancy, which are jet engine travels. So also the other things are the thrust levers, like the thrust reverse, the speed brakes, the flaps position, the horizontal tail trim, stabilizer, drop tab, and cutout switch, the fuel flow control switches for the engines. Also, the flight controls, the control column, you control the horizontal tail of the elevator using the control column, and the control wheel, you control the ailerons and the spoilers. So this is the yoke of the Boeing 777, and also the rudder pedals for the vertical tail stabilizer. So I'm going to show you now. You can see here we have the yoke, the control column for climb and descent using the horizontal tail elevator, and also make bang rolls, so left bang rolls right, and also left and right, the rudder, the vertical tail, the rudder pedals. So you can use them having coordinated flight controls simultaneously, and also they are interconnected between the left and the right. So you can see them moving together. You can see you can climb. So you can see over here outside the flight controls movement like this. So you can see also I'm gonna show you later that. So you can see I'm using this size here, the Lszh Extreme 3D, for controlling the flight controls, which is interconnected with the yoke over there. So you can see I can pitch up and pitch down the aircraft. Also bang roll left and bang roll right, using the ailerons and the spoilers. So you can climb, you can descend. Use the horizontal trim stabilizer. Also, you can use so using this side stick, I have direct input into the yoke of the Boeing 777, the flight controls. So I will show you how I control the horizontal tail and the vertical tail and the ailerons and the spoilers. So you can see here, so I can pitch up, pitch down, bang roll left, bang roll right, like this. And also use the thrust levers like this. Increase and decrease the thrust by the engines up and down, using this slider over here. So I have full control of the aircraft every second I fly. You can see the side stick deflection is proportional to the yoke over here deflection. Also I'm having, as you can see, horizontal tail, vertical tail, the rudder pedals, left, right. So you can see here outside I can also use the side stick like this. I'll show you how to use the flight controls from the outside view. So you can use the side stick like this. You can literally climb the aircraft like this, climb up, descend. So this is the flight control input, climb and descend. You can see the tail of the aircraft movement like this. Climb, descend. Also the vertical tail like this. And now the other ones like this. Make a left turn, then make a right turn like this. So this is how you use to fly the aircraft in flight. The flight controls, and I will show you inside again the overhead panel, how to use other systems. I'll talk to you about also the cockpit inside. So also you can see we have the overhead panel. Over here we have the electrical, the left and right engine, IDC, the grid drive generators that produce alternate current 120 to 100 volts, 400 shares alternate braking. So this is from the left and right engine installed in the gearbox of the turbo engine. We have 120,000 kilovolts or 102,000 watts from the left and right engine, 35,000 watts from the backup generators. Also the APU, another 120,000 kilovolts. We need the APU. We're gonna start it for the engine start demonstration. Start the engines in the ground. It's a smaller turbine auxiliary used in the tail of the aircraft, used to start the engines in the ground and as a backup in flight. Also we're gonna need the batteries and some pressurizer from the APU to start the engines. I will show you also that. I will show you the ability and data units, reference unit, primary flight control computers, parameter turbine, the oxygen for the passengers, the hydraulic system, the left and the right engine, hydraulic pressurized and electrically pressurized hydraulic tanks over here, which we need for the flight controls I show you, and also for parking brakes, landing gear extender, track, and other systems like the thrust reversers from the engine. Also we need the pressurizer for the C1 and C2 hydraulic air pressurized tank. We have also the AC, the electronic engine control for the engines, the auto start. We can dump some fuel in flight. We have the fire extinguishers. So this is the auto start system and electronic engine control for the engines. The ADIRU, the air data units, reference unit, I will talk to you now. The left and the right wing fuel tank, the fuel booster pumps, and the center tank and the crossfeed valves. So this is the fuel system and the fuel jettison. And this is the cabin pressurization and the pressurizer from the left and the right engine, and also from the APU. We need pressurizer from the APU to start the engines, and pressurizer from the left and the right engine for hydraulic fluid pressurization, wing and engine anti-ice. Over here, air conditioning and ventilation, and hydraulic fluid pressurization. So thank you very much one more time for joining me. I'm Thomas Hatsios, the German-American pilot flying the Boeing 777-300Erx in tonight's flight. I'm going to start now showing you all the systems of the aircraft. So we have here, you can see, we have about an hour left for this video to end for the record. You can see also where we are located. So this is about a few more minutes left. So you can see here we have also the flight controls I was showing you before. So we have the primary flight display. You can see the airspeed indicated, the airspeed tape, the airspeed selected from the autopilot, flight direction, the panel, the ground speed, the magnetic heading and track, the magnetic north pole, the north pole, and the magnetic variation depending on where we are in the world. We have the barometric pressure of the outside atmosphere over here, 29.92 inches of mercury, the barometric altitude based on the barometric pressure and the altitude selected from the autopilot and flight direction system panel, the radio altitude above the ground level and pitch ladder in degrees. You can see the pitch ladder 2.5 degrees tick marks, 2.5, 5, 7.5. So this is the pitch altitude 10, 12.5, 15, 17.5, 20 of positive pitch altitude or negative. So you can see also the vertical rate of climb in the center of the aircraft over here. We have the bank angle also limited degrees, the angle of attack of the aircraft as it flies in the flight mode and consider the autopilot of the throttle, the down vertical navigation modes. These displays how fast the aircraft climbs and descends. So This is actually what you need to know. You have a positive pitch altitude, but you don't know whether you climb or you descend. You have to look at this place here. This tape, so if the aircraft climbs, you will see the needle moving up here in the positive values. If it descends, moving down below this altitude line. We have also the GPS position here. You can see the airports, the distance they are located. We have the magnetic heading and track again, magnetic north pole to north pole. You can change magnetic north over here. Normal true. So now we have the geographic over here, north pole for navigation. So you will see difference in the map track like this, true and magnetic here. So we have also the magnetic and the normal. So we can change back. We have also, which is a few degrees, it's 329, like 4 degrees different. We have also for this place, we have the inches of mercury, hectopascals, meters. So you will see the meters here displayed in the feet, and 1013 hectopascals. So we have the autopilot over here, the flight director system panel, the FULLL panel, electronic flight instrument panel, some switches for the system. So we have the auto throttle left over here. We can turn off the auto throttle left. It will display auto throttle left off. We have the auto throttle right off also. The flight director. So you can use the flight director on and off to switch off a mode to reset. So if you turn on the flight level switch, you can turn off the flight level switch like this by turning off the flight director. It turns off this as armed mode. You can also use to turn the airspeed. You get airspeed or Mach, the LNAV and the VNAV, the climb continues, auto throttle, the heading and track over here, the bang angle. You can select like this by pressing the switch also. So you can select the runway heading and this airspeed. Then we have also a couple more things. We have the altitude here. You can select the altitude, the target altitude. So maybe we're gonna use this also. We can set the other side flight director also and the autopilot on like this. So now we have the autopilot on. This is the autopilot on with the flight level change speed and the heading hold. So we have also the autopilot off with the same mode. You will see the flight director flight level change speed instead. So now we fly manually with the flight director here displays. So this is gonna be our target. Airspeed 253 nautical per hour, and the target altitude is 5,300 feet or 7,700 feet meters from this altitude. So now we have also the heading here, 136. You can see magnetic also. So we can use the flight controls now for steering instead of the autopilot. So now we can show you how to turn on and off the autopilot like this. like this, the autopilot, and like this is off by pressing up this switch. So you will see the warning, and the autopilot is disconnected over here with this red warning over here, and the flight director is on. So we turn on the autopilot again, the warning is off. We need also so we're gonna use the altitude hold also over here. It's also depressible. So we have the altitude hold over here, heading hold, autopilot on, and a couple more modes. You can use either flight level change or altitude target out. So this is different climb mode, and also we have, you can see the altitude here. We have this switch here for the autopilot flight director system panel, which is the vertical speed or flight path. So you can use this slider, you can move it either up or down. You will see you can set a -3.5. So you will see this is gonna be a descent. This green switch means the mode is on. There is a green switch on. So you will see when the switch is off, you see so you see this is the descent rate in the pitch ladder. So it's -3.5 degrees. This is gonna be a descent using this FTA mode, heading hold, and also from this cruise already. So we can use the climb now mode over here. So we're gonna use again this switch, this slider with this. So we're gonna use it the other way. You will see here. Now we're gonna use the climb. So you will see here the climb. So it's gonna give a climb command to the aircraft. The FTA with a heading hold. Your desired rate of trigonometric angle increase the steepness of the aircraft climb. So you will see 3.5 degrees over here in the pitch ladder, between the 2.5 and the 5. From this altitude over here to target altitude 35,300 feet or 7,710 meters, and this target airspeed 253 knots. So we have the flight level change speed. We have also the other mode, vertical speed. So we can use tens, hundreds, and thousands of feet per minute, like this. You will see -3,500 feet per minute. So we have -3,500 feet per minute for a descent over here. So it's gonna be the descent rate, -3,500 feet per minute, displayed in the vertical speed indicator. So we're gonna use now the climb rate over here. So we have the +3,500 feet over here. It will display +3,500 feet per minute climb over here. So you will see +3,500 feet per minute in the vertical speed indicator, and this tape over here you will see it's marked again as vertical speed heading hold. So this is all the modes of the autopilot. I'll show you how to disconnect. You can also use this switch to disconnect the autopilot. Press this switch out in the flight controls. The autopilot disconnect. You will see the warning one time. The autopilot is disconnected. Or you can move the flight controls to do that. And then press one more time here the switch. It will confirm the disconnect action and will cancel the warning. So now the autopilot is disengaged, and we have this mode with the flight director. Also the vertical speed with the flight director for this climb rate and this target altitude. So we have also, perhaps this is for picking up in the takeoff. So I'm gonna show you also the flight controls. I show you the thrust levers, the upper and the lower ACAS, and indication of the system display, the overhead panel. So we have the thrust levers. You will see on the display the upper and the lower ACAS and the indication of the system display. Over here we have also so this is the plus 3, so we're gonna have an aircraft coming in. We're gonna track this, so maybe 10 minutes away. So we're gonna have here this, you will see we have the terrain override. We have the landing gear extend and retract over here. Landing gear, you can see the landing gear up and down in the upper ACAS. This display displays all functions for the engine, the left and the right, some other systems, warnings, like the doors. You can see the fuel pump center left. The total fuel on board over here, the aircraft in thousands of kilograms, 47,100 kilograms in the temperature of the fuel. This is the mark of the aircraft. We have the landing gear, as I told you, the limit for retract or extending the landing gear, alternate gear, lock override for the landing gear, the auto brake and the flaps limit. So we have the auto brake set. Reject the takeoff. So we have also the pressurizer from the left and the right engine, and the forward and the outflow valves for the cabin pressurization system and the rate of the cabin of the aircraft. So these are a few things you will see around the engines. So we have also the flap settings. You can move the flaps up and down like this, increase and decrease the surface area of the wings, retract, extend. You will see the flaps position here and the flap limit, as I told you here. We have also the speed brake, extend and retract. You can retract and you can extend when the thrust levers are at idle. Notable, but when you have the thrust levers at idle, the speed brakes extend and you move the thrust levers forward, the speed brakes retract automatically. So I will show you now the navigation display over here. You can track something like an aircraft that is coming in. You can see it blinking here. You can also see the navigation display over here. You can see the diamond is coming closer. It's an aircraft. So you can see the altitude difference is plus 2,600 feet and it's heading down closer to the airport here in the runway. So you can see moving in front of the navigation display using the transporter. Now you can see the arrow down symbol. The arrow means the aircraft is descending. when the arrow is up is climbing. You can see plus 2,300 feet. You see the distance is 5 nautical miles away from us, and you can see the traffic now. The warning has come in. It's plus 2,000 feet. You can see track down plus 1,100. You can see the aircraft is coming down here for landing. It's approaching the runway, and also the aircraft is blinking. You can see also the display now is plus 1,300 feet. It's between the 5 and the 2.5. It's closer. Now it's about 2.7 nautical miles away. 2.6. It's almost 2.5. 11 plus 1,000 feet above our aircraft. So we're gonna keep tracking the aircraft in front of us. You can see the red beacon also over here. It's getting closer and closer. So you can see now it's plus 700 feet, plus 500 feet. Plus 600 feet over here. I'll see the radar. You can see the traffic here. Here's this aircraft here, the traffic and the aircraft. Plus 200 is the yellow warning, and you have it. It's coming in now in front of you. So this is the aircraft traffic collision. You can see other aircraft. You can spot them over here. You see the aircraft is coming in. So it's closer to our own aircraft over here. So this is all for the traffic collision avoidance system over here. Traffic collision takeoff system. You can set it here. You can also test. You can see other aircraft flying around you. So we're gonna set this range. We're gonna see some aircraft farther away. They're flying at different altitudes, plus 9,000, plus 7,500. We have two diamonds over here. So I'm gonna show you and talk to you about the thrust levers, how to use the thrust levers, also other flight controls. So we have the thrust levers. We have the horizontal trim stabilizer over here in the pitch trim. So this adjusts the horizontal tail of the aircraft over here. This is moving up and down the horizontal tail. In total, you can pitch trim. Also, you can pitch trim the vertical tail and the ailerons and the spoilers. You see the ailerons and the spoilers here. So this is the horizontal tail, the elevator, the vertical tail, the rudder, and we have over here, as I told you, moving these things. You can also pitch trim up and down. Use the rudder pedals, and also use the rudder trim here and the aileron trim. When you use the pitch trim for the horizontal tail, this is the manual trim order, and you have the autopilot and auto throttle have an automatic order. So we have also the normal here trim tab, and you can see the horizontal tail. As I show you, the stabilizer position in degrees is moving up and down. You can balance the aircraft in flight, nose down and nose up. You can set the desired. You have the green band, so you were to set it up for flight or takeoff. We have the parking brakes on and off. So the horizontal trim stabilizer, very important. If you have a failure over here of the hydraulic system, the left or the right, C or the R over here, the auto trim I told you about, the autopilot and the auto throttle over here will have a malfunction, so you'll have to disconnect, open this switch, guarded switch here, disconnect from the normal, the CNDR, the stabilizer, the CNDR stub over here from the normal, to cut out. So this is the CNDR hydraulic system failing, and you disconnect the auto trim function, so you will have only the normal, the manual trim for the horizontal tail. We will keep pitching up and pitching down using this switch. So I will show you the rest around the flight controls, also the thrust levers, the weather radar, terrain radar, radio communication panel, the fire extinguishers, left and right engine, the fuel flow to the left and the right engine. I told you the speed brakes, then retract, flaps, up, down, takeoff, go around switch. I told you the auto throttle over here, connect, you have the auto throttle and you take manual control of the engine. Press this switch over here, the takeoff, go around, and the thrust reverser for the engine. So if you have the speed brakes extended and you move the thrust reverse, the speed brakes extend automatically. So you have the thrust reverse over here, and you see the thrust reversers in the blocker doors of the jet aircraft open. So you can slow down the aircraft in landing. You can extend them again. And here the front view. So you can retract and extend again, and retract and extend again. So this is how to use the thrust reverse to slow down the aircraft. So we have the thrust levers I told you. We have also the indications I will show you. We have the thrust levers move forward one at a time like this. You will see we have variable thrust. You can see the right engine having more thrust than the left, compared to parking brakes, fuel pump. So we can move both to the same position. We use variable thrust mode for like an emergency without a failure. So now we use the left engine forward. You have more thrust into the left engine. So we use both engines the same. Now we'll show you here the upper and the lower ACAS. We have the displays. You can see we have the N1, which is low speed starter and start, the low pressure compressor and turbine of the turbo hunter, which is engine, the left and the right, the exhaust gas parameter per engine, the bleeder, the pressurizer from the left and the right engine, 34 psi. The N2, which is the high speed starter and start, the high pressure compressor and turbine of the turbo hunter, which is engine, the fuel flow per engine per thousands of kilograms to 1,000 pounds, fuel pressure, oil temperature, oil quantity, and the vibration of the N2 stage of the engine. So if you move the thrust levers forward enough, you modify the thrust commanded to the FAREX. So the FAREX are the fuel authority. So the FAREX are the full authorities, electronic control computers, one installed per engine. In the gearbox of the engine controls of the turbo conduit engines. We have the General Electric jet engines, I will tell you, E90 turbo conduit engines in aircraft. So the FAREX control monitor and display, the N1, which is low speed starter and start, a low pressure compressor and turbine of the turbo conduit engine, the exhaust gas temperature per engine. The N2, which is the high-speed starter and starter, high pressure compressor and turbine of the turbo conduit engine, the fuel flow per engine per hour, oil pressure, oil temperature, oil quantity, vibration of the N2 stage of the engine, fuel flow to the engine, fuel metering unit, fuel heat exchanger, pressure inside the engine start now. If we have an overpressure inside the engine, we have the Hatsios can command the upflow valves into higher of the 5th and the 9th stage of the turbofan, which is to higher setting to relieve the overpressure from inside the engine. We have another pressure to close them to a lower setting to increase the pressure inside the engine. Also, we climb from the sea level all the way up to the cruise level at 20,000, 30 and 40,000 feet above the sea level. The air pressure, density, and the oxygen level of the air is becoming less than half than that of the sea level. Also, the temperature of the air is facing -30, -40 or less degrees Celsius. Also, the airspeed of the aircraft is 2 or 3 times faster than that of the ground level. So as we fly from the sea level up to the cruise level, we have a different fuel mixture request every second because difference of the air quality and also the fuel of the air rate intake from the front fan into the air into the compressor of the jet engine. So we have fuel mixture adjusted by the Hatsios. Also, as we descend vice versa from the cruise level down to the sea level, we need to do the same. So this is done automatically. It's a good thing to have the Hatsios installed into your engine. So we're talking now about neutral thread second flow max motion, about the new fluids are natural and anesthetic units, so some principles about flying, about the lift created from the wings that overcomes the weight of the aircraft, and the thrust from the engines overcomes the kinetic and static friction into the aircraft. We have 254,000 kilograms of takeoff weight, or about 531,000 pounds, which is below the maximum takeoff weight. We have about 30% only of fuel on board, making maximum takeoff. So we're gonna make the calculation for the takeoff speed. So you can see here we have the outside view of the aircraft. You can see the mean aerodynamic core position, where is the maximum aerodynamic lift created, the vectors from the left and the right engine. The aerodynamic core position, also where the stall begins, the airflow becomes detached from the top of the wings, the center of gravity transverse this vector, the wing to the wing tip, and then longitudinal from nose to tail vector. Also the lever arm from the center of gravity all the way back to the horizontal tail over the airflow, the air mass per second times the acceleration of the air gravity is the lever arm and moment arm. Also we have you can see the bottom surface of the wings is more flat, so as we accelerate for takeoff, the airflow of the air mass using the Bernoulli theory of fluids is moving slower, so we have higher air pressure below the wings, which pressurizes the aircraft pumping into the air. Also the top surface of the wings, the airflow of the air mass is moving much faster, so we have lower air pressure, which sucks the aircraft wings up into the air. So this is some very quick aerodynamic principles. Very quick. Now I will show you the overhead panel and the system's display. I will make the engine start demonstration and complete flight. So go over here. I will show you the overhead panel. So we have here the overhead panel. You can see inside the cockpit. So we have the systems, as you can see. So this is for disconnecting the hydraulic fluid from the flight controls. For maintenance of the circuit breaker, you can reset if you have them on function. In the electric system, the flap setting, the autopilot. And this is the overhead panel. We have the ADIRU, the air data and user reference unit. I will talk to you later. The APU, we can start the APU like this. We need to start the APU switch. You can see battery on and APU generator on. Primary flight control computers on and off like this. Process symmetry compensator, left engine, right engine, and the backup generator. So this is electric system. The flight control computers, the hydraulic system. You can use, you can turn off the hydraulic pumps. I'll show you what happens We have also the rammer turbine for hydraulic and electric. We have the passenger oxygen. So you will see the FULLL coming up, and we have here some systems failing because we have this. You will see alternate flaps, and you will see all the flight controls, hydraulic pressure, demand Lszh and R. You will see all the hydraulics and the stabilizer, spoilers, no auto lamps. So we have all the flight controls function mostly. So we turn on the hydraulics like this, all hydraulic switches, and then to the auto position. So we have also the cargo fire extinguishers, electronic engine control for the engine, normal and alternate, the auto start system for the left and the right engine. So this is how you use the auto start. On and off. You can dump some fuel in flight, select the nozzles and how much to remain. If you want to lose weight, this is the left and the right wing and the center tank, the crossfeed valves, the forward and the aft, the fuel booster pumps. You can see the center tank is empty, the wing and engine on the ice. So this is also the lighting system and the windshield wipers, the left and the right. And this is the cabin pressurization. Here, open, close, you use manual, you use the outflow valves open and close when you glide or descend to increase or decrease the pressure of the cabin. And the pressurizer, also we need pressurizer for starting the engine. When you see air conditioning and ventilation, hydraulic fluid pressurization. So you can see the hydraulic fluid pressurization, duct pressure. Here you will see in a couple of seconds. Here we have a hydraulic pressure, demand C1 and C2, so we lose some flight controls like this. Also we cannot start the engine, so we need to reset the overhead panel, the pressurizer. So this is all for the overhead panel system. Now we'll show you how to make an engine start demonstration. So we have the display here is the flight management computer and the systems display. So we're gonna have here the systems display. On display you can see the engines, the status, you can see the hydraulic pressure, the APU is running, the oxygen level, the checklist, the normal menu, communication, navigation. Synoptics, the doors are closed and the cabin can be pressurized. The landing gear, you can see the pressure of the tires and the temperature of the brake. The electric system I show you in the overhead panel, left engine, right engine, backup APU. You can see the voltage of the battery and the charger, discharge over here. The hydraulic system, left engine, right engine, C1 and C2, where the hydraulic system goes. 3000 psi, 3000 psi, 3000 the quantity of the fuel. Left and right wing fuel tanks, left engine, right engine, low and high pressure fuel valves, crossfeed valves on, center tank is empty. You can see how much fuel you have in the left and right wing, and the APU is fed from the left wing fuel tank using the DC motor. Also you can see the minimum fuel temperature over here, minus 37. The pressurizer from the left and the right engine from the APU. Also we need to start the engines and the flight controls, the last things we need to pay attention to this over here, so we can move the flight controls around by their side. You will see all the flight controls like the horizontal and the vertical tail, the train stabilizer, everything is working normally. So we go back to the modes, engines, Ilsloc cockpit. So we need to restart the engines to make a demonstration. So we turn off both engines like this. Fuel control off. You will see the overhead reset over here also. We have the engine slowing down, engine auto start left, right, and engine start down. You can see no fuel flow over here. So if we look here, you will see both right and left engine off, but there is pressurizer from the APU. So we need to let the fuel flow on like this, left and right, and we have the fuel running back into the engine. Fuel flow from 0, you will see it will pop up, and we will have both engines running, both right and left. So you'll see the spinner increase, and we have the engine ready for takeoff. So we need to do one last step over here. The menu, the FMC, Boeing 777, position initialize, the reference airport, Lszh, 0 fuel weight, gross weight, reserves 5%, post index 100, minimum fuel temperature, the route from this airport, and Lszh, copy paste, back to this airport, runway 14, departure, Lszh 12, arrival, Lszh 14, Transnegria 1 Alpha. So this is the route we're gonna use. Next page, cancel the discontinuity, activate and execute, and we have the flaps, center of gravity automatically with the takeoff speeds V1, V0, V2 for this gross weight and this runway. So we need only come here. We need so we advance the thrust levers and disarm the parking brakes. So we take it the clearance for takeoff from the air traffic control like this. We only need to steer into the runway, advance the thrust levers. So this is our beautiful jet aircraft, the Boeing 777. So the runway is open. So this is the outside view. We're gonna have this view for takeoff also. Everything is set inside the cockpit, so you can see also the heading here, the nav. So we're gonna have different range come now. Advance the thrust levers, the flaps are set for takeoff. And the fin stabilizer. So we're gonna have over here the thrust set. Advance the thrust levers moving forward, and disarm the parking brakes and go, and align with the rudder pedals. So here we go. We have 100 knots. V1, re-rotate, V2, align with the rudder pedals also. So here we go. We have positive rate of flight. We track the landing gear. So you can see we can pitch train a little bit the aircraft like this. We don't need to climb so fast. So we are 2,400 feet above the ground level. You can see we are 4,400 above the sea level. We climb with 5,700 feet per minute. The airspeed is 220 knots. The flaps also the limit, and the target airspeed, target altitude, and the terrain, and now the map over here. So we have also the engine set over here, maximum takeoff, and the autopilot set. So you can see we can start turning now. Make a turn. You can also have the outside view. So we keep accelerating, 233 nautical miles per hour, 10,000 feet crossing. So this is a beautiful view here. We need to make a turn, and I will show you the outside view. Also pitch a little bit more level. So we have about 13 more minutes for this flight. So this is the beautiful view of the Boeing 777 as we climb with 600 kilometers per hour over here. So this is a beautiful jet aircraft, the Boeing 777-300Erx. You have also the view, the beautiful night sky, and Zurich, the Switzerland. So we go embark. Another turn now. So we keep climbing. You can see we keep climbing while we turn. You can see the positive needle. You can see we are above the stall speed, way above, and the max speed is 0.45, and we have to follow this track. So we have a few more minutes to go. We have to follow this climb right here. I will show you the needle. We have to see also the outside view of my aircraft flying around here. So we need also use the legs, the first leg here. So we have the leg spread here, you can see, and we have to follow these waypoints as we climb. You will see the distance to the waypoint as we climb. I'll show you also later. Keep climbing this way also. So we have the Germany in front of us, the Bayern Munich, the France in this side, and the Switzerland in the other. So we have another 10 minutes for the video to end with the record. So you can see the autopilot settings here, the thrust, 32. So here we are above, we keep flying, we're having the chemtrails and the contrails, and we have 9 more minutes left for this flight. So this is our spacecraft view, the Boeing 777-300Erx. We're flying with 650 nautical miles per hour. So we're flying here. We have also the frozen vapors and the galactic view. So we're flying 33,000 feet above. Here we have the Germany, the Bayern Munich in this side in the front. Now we need to start going back. Need to start going back home. So we're gonna make a turn. Also increase the airspeed. Pitch swing. Fix a little bit the stabilizer and increase the airspeed. Also the flat, the truck, and so many flat. So we need to make the turn now. We keep climbing, make a smoother maybe turn over here. So we have the frozen vapors, the chemtrails and the contrails, so we can see from the jet engines. Also the view of the lake, the St. Gallen Lake here. We are 34,000, excuse me. So we have this view, also the Bayern Munich and the France on this side, the Germany on this side. So this is the Boeing 777-300Erx. We fly with about 980 kilometers an hour, 300 meters per second. So we have about this beautiful view. So this is our spacecraft for the night. This jetliner, this beautiful aircraft. And we have the Galaxy, 300 meters per second. And also we need to steer around. We have the cruise level, so we use the autopilot to connect now. So we're cruising here in the cruise level with the autopilot connected. So we need to steer the last waypoint here. So you see the autopilot will adjust on the cruise level like this, the autopilot is on. And we're gonna have also last waypoints and the approach and landing reference speeds. So we're gonna start descending in a couple of minutes. I've done this already. So this is the beautiful view, and this is now we're going for descent. So this is going to be commanding also the speed brakes and the thrust levers slowing down. And to use the autopilot to disengage. So we keep descending. We're flying manually, as you can see. We will slow down most of the commanded airspeed, and we're gonna use so you see where we descend over here for the approach and landing. Increase the thrust. We need to align with the rudder pedals. And also use here we are. Idle thrust. So idle thrust here. Here we are. Touchdown. Parking brakes and reverse thrust. Full reverse. So that was the flight finish. We had a beautiful landing. You can see the nose wheel is perfectly safe with the landing gear, the left and right landing gear. You can see the nose wheel is perfectly normal.